everyone, in this video I'll be doing Advent of Code 2021, day 13. I'll be doing the puzzles and then explaining them afterwards. If you'd like to see my code, that'll be in the GitHub repository, which is linked to down in the description. And let's get started with today's puzzles. Alright, so today's puzzle is called Transparent Origami. After navigating the cave system from yesterday's puzzle, we have reached another volcanically active area of the cave. We need to do some thermal imaging, which requires something more convoluted right now because we need a tool from the submarine, but that tool needs a manual. And this manual has not been used by the elves, so we actually need to decipher what it says by ourselves. So it's a bit of a convoluted story, but I love convoluted stories. So our paper, or the manual, is marked with a bunch of dots, and the dots don't make out anything special right now, but what we have to do is complete a bunch of folds of the paper, and then it'll reveal some code, because this paper is transparent, and dots will line up and stuff, and it'll make some cool image at the end that has a code that we need. So there's a bunch of explanations here. Basically, we continue folding the paper along different lines until points line up, and at the very end we'll get some kind of code. In this case, in the example, we end up with an O, or a square, or a 0, or something. So part 1 asks us, fold the paper given the first fold, which is described as a vertical or horizontal line, and after all those points match up, some of them might overlap. What is the total number of dots that are visible? And overlapping dots only count as 1. So how I did this was, instead of keeping track of the points, instead of keeping track of the entire grid, I only keep track of the points. So in the actual inputs, we can see that these numbers can go quite large, like up to the thousands. So if we keep track of a 1000 by 1000 grid, that's going to take up a lot of memory and a lot of time. So ideally, we don't want to keep track of the entire grid. We only want to know where the points are, because that is what's important. So how do we keep track of the points? Well, I'm going to use a set, because sets have the special property that no 2 points or no 2 elements can be duplicated in the set. And that's exactly what we want in our case, because overlapping points only count as 1 point. So I have this giant code for reading the input, which probably is unnecessary, but reading it is always a bit of a hassle when you have like 2 distinct parts. So there's like 700 something lines of the points, and then a few lines of the actual lines, or the lines that we need to fold along. So that inputs, I'm sure you can figure it out by yourself. It's not too hard. Then I made this helper function, which I will explain. It's used to reflect a point around a line. So every line is either vertical or horizontal. Let's take an example of x equals 5. And let's say our point is, let's try the coordinate axes here. So x equals 5 is this line right here. If we say that this is x equals 5. And let's say our point is like 6, 3. Well, intuitively this point is going to land on the other side of the line. And by analysis we can tell this is going to be, well, this is definitely not to scale. We should probably draw this closer. Or we can just change the coordinates a bit. 10, 3, right? Maybe not 10 ideally, maybe 8. Then what's that going to be? That'll be 2, 3. And how do we know that? Well, if we draw the line connecting these, we know that the point, when reflected across the line, is going to keep the coordinate that is not part of the line. So basically, the y coordinate is going to stay the same in our case. And we know that these two distances are equal, which is the property of reflecting over lines. So this distance is going to be 3 on the right side, and it's going to be 3 on the left side. So in summary, the distance from the original point, so let's say that's point 0, and this is just for x coordinate. You can extrapolate to y coordinates. And then line 0, generalized, this is 8, and this is 5 in our example. What we know is that point 0 minus line 0 is equal to line 0 minus the new x coordinate. And what this simplifies it to is the new x coord is equal to 2 times the line coordinate minus the point coordinate. And there you go. There's the equation extrapolated using some very basic algebra. That's exactly what I have here. So if the line, I'm describing the line using a tuple here, a pair of points, a pair of numbers, which describes the line. If the first number is non-negative, that means, if the first point is non-zero, then it means it's a vertical line. And if the second point is non-zero, it means it's a vertical line. I'm sure there's better ways of doing this, like, I can think of a few, but this is just how I'm doing it. Makes it a bit more convenient, perhaps. So if it's a vertical line, so x equals something, then we use the same formula. We keep the y coordinate the same, and then we modify the x coordinate to be flipped over to the other side of the line. And if it's a horizontal line, then we do the same except with the y coordinate. So there's that function that just reflects a point over a line, where the line is this form. Or it could be maybe like 0, 3 for vertical line. Okay. Now we do the first fold. Oh, hang on. I think I actually swapped these around. Okay, so yeah, that's not important. Basically what we do here, we just take the first fold. In this case, that's x equals 655. So that would be described with pair 655, 0. This is the first fold line. And then using our handy dandy function from earlier, we reflect all of the points over this line and add it to a new set describing the locations of all the points after the fold. I did some generalizations here just to account for whether the fold is vertical or horizontal. For the second part, vertical folds, we just reflect all the points that are to the right of the line, because if it's to the left and we reflect it also, that's just going to be mirroring the entire thing around. So we only want to reflect points that are going to like lay on top. So that means x coordinate will have to be greater than the x coordinate of the fold. So we just reflect all of those points onto the left half, and yeah, we just add that to the set of new points. So old points on the left half are going to stay where they are, and all the other ones are going to go on top, and we're not going to count duplicates because we're using a set data structure, which keeps no duplicates. Yeah, after that we just count how many points there are in total and print that out. So that's part 1. For part 2, we have to do all the folds now. And thankfully, we did a lot of the work in part 1 already. Instead of only doing the first fold, now we do all of the folds. So it's literally the same code. We just do all of the folds in order. After doing all of the folds with the same code, then we need to actually print out this grid, because after the folding the paper is done, it actually forms some nice letters, which is pretty cool. I think that's a nice thing to do instead of just counting how many dots there are. Makes it a bit more fun. We loop through the grid. We loop through Y first, because when you're printing out stuff to the console, it goes line by line, which is increasing Y coordinate, and then we go X. So we just loop through this like 50 by 6 grid and check if each point is a dot or not by checking if it's in the set. And if it is a dot, we print out the like a pound sign showing it is a dot, and otherwise it's blank. And after we do that, we find it makes this cool pattern right here. And reading this and putting it into the website gives us the correct answer. So I think this is a pretty cool pattern. I like how it's displayed right here. So yeah, that's it for day 13. If you have any questions or comments, anything you would like me to clarify, I'm happy to answer your questions in the comments. If you want to see the code, again, that'll be in the GitHub repository, which is linked to in the description. And I'll see you tomorrow for day 14. Thank you for watching.